This just means take the derivative of this function and plug in 2. I would start by rewriting it as 4x to the negative 1 plus 5x minus 1. Then the derivative will be negative 4x to the negative 2 plus 5. And if we evaluate this at 2, then we get negative 4 times 2 to the negative 2 plus 5, which means that f prime of 2 is negative 4 over 2 squared, which is 4, plus 5. That's negative 1 plus 5, so 4. So I think the answer is A. 2, the integral of 6e to the 3x. This is an indefinite integral. We're just finding the antiderivative. If you wanted to use guess and check, then you would, I would probably guess, well, for one thing, the 6 is a constant multiple. I would just pull it out like this. So you're just focused on taking the antiderivative of this. I would guess and check this. I would just say the antiderivative of e to the 3x is basically going to be e to the 3x. But if you check this by taking the derivative, you'll see that because of the chain rule, you get an extra factor of 3 that you don't want. So actually, the antiderivative of e to the 3x is 1/3 e to the 3x. That becomes 2e to the 3x. If you wanted to, and so that, plus c, of course, plus c. So the answer, it looks like, would be A again. If you wanted to do u substitution, you do u equals 3x. That's going to take longer, but if you want to, you can do it that way. Number 3, we have some graph. We want to know what is the limit as x approaches 1. Well, at 1, we can see that all kinds of weird stuff is happening. In order for the two-sided limit to exist, the left and right-hand limits must agree. The left-hand limit is definitely 3. The right-hand limit is 1. Those are two different numbers, so this two-sided limit does not exist. So the answer is D. Number 4, if f prime of x is blah, 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 and f of 2 equals 3, then f of 1 equals, I would say that this is a later value equals earlier value plus net change problem. You could say f of 2, that's the later value, equals f of 1, that's the earlier value, plus the integral from 1 to 2 of f prime of x. Plugging in, that tells us that 3 is equal to f of 1 plus the integral from 1 to 2 of 3x squared plus 2x dx, which means that 3 is equal to f of 1 plus, okay, what is the antiderivative of this? It would be x cubed plus x squared, and we're going to evaluate that from x equals 1 to 2, which tells us that 3 is equal to f of 1 plus 3 cubed plus 3 squared minus quantity. Sorry, not 3 cubed plus 3 squared. 2 cubed plus 2 squared minus 1 cubed plus 1 squared. So that's 3 equals f of 1 plus 8 plus 4 minus 2. So 3 is equal to f of 1 plus 10. So negative 7 is equal to f of 1. That's one way to do it. If you don't like that, here's a different way. You could say, I know that f prime of x is equal to 3x squared plus 2x, which means that the original function f is just going to be the antiderivative x cubed plus x squared plus some unknown constant c. Well, what is c? You can find it by using the value that they give you. F of 2 is equal to 3. I can plug that in and say 3 is equal to 2 cubed plus 2 squared plus c, which means that 3 is equal to 8 plus 4 plus c, which tells me that c is equal to 3 minus 12 is negative 9, which means that my original function is f of x equals x cubed plus x squared minus 9. So therefore, finally, f of 1 must be 1 cubed plus 1 squared minus 9, which is again negative 7. Number 5, During an evacuation drill, people leave the building at a rate of R of t people per minute, where t is the number of minutes since the start of the drill. Selected values of R of t are shown in the table above. Using a right Riemann sum with 3 subintervals from the table, what is the approximation of the number of people who leave the building during the first 15 minutes of the evacuation drill? So this is the rate at which people are leaving, and so it's essentially like the rate out function. So it's kind of like a rate in, rate out problem, except there is no rate in, it's just rate out. So this is like a rate out function. If you want to know the number, the amount of people who leave the building during some time interval, then you just integrate the rate out function over that time interval. So to find the number of people who left during the first 15 minutes, I would compute the integral from 0 to 15 of the rate out function. Of course, I don't have a formula for this guy. All I have are some selected values. So I can only approximate the value of this integral. And the problem's telling me to use a right Riemann sum to do that. So the 3 intervals that you would be considering would be the following. The values that they give you occur at the t values of 0, 5, 10, and 15. So the first interval would be 0 to 5, the second would be 5 to 10, the third would be 10 to 15. What is the value of the Riemann sum? Well, imagine drawing a rectangle above each of these subintervals. The rectangle on this first subinterval, its width, of course, is 5. How tall is it? Well, since this is a right Riemann sum, the height of the rectangle is determined by the value of the function at the right endpoint, which is 100, the value of the function here at 5, so that's 100. Plus, the next rectangle also has a width of 5, but its height being determined by the value of the function at the right endpoint, which is 10, would be 75. And then finally, 5 times the last guy would be 55. So that's 500 plus, what is 5 times 75? It's not 500. Is it 375? What is that exactly? Yeah, I think it's 375. Yeah, because 5 times 70 would be 350 plus 25. And then plus 5 times 55. What is 5 times 55? I don't know. I mean, maybe it's about 250. I mean, the thing is, I don't really need to know exactly what it is because it's a multiple choice question. Like, I just have to figure out which one is in the ballpark. Like, what is this number equal to, right? It's obviously not 230. Could be 1150 or 1375. It's definitely not 2,750. So which one? I mean, I think it's 1150, right? 5 times 55, what would that be exactly? I mean, 5 times 50 is 250, plus another 25. I think it's 275. This problem's kind of annoying for the arithmetic. So that's 875 plus 275. So that's 1,000 plus 150, 1150. Yep, that's right. Cool. So it's B. But yeah, you can see there, sometimes, like, you know, if the arithmetic gets kind of crazy, sometimes you're able to just look at the answers and be like, well, it's obviously not this one. It's obviously not this one. It's got to be this thing here, even if you can't get the numbers exactly right. Number 6, they just want you to find the derivative of this function. You need to use the product rule. So y prime is 2x times e to the x minus 1 left alone plus x squared times the derivative of e to the x minus 1, which is just e to the x. That's none of the answers, but that's because they've chosen to distribute everything and collect terms. So if I distribute the 2x, I get 2x e to the x minus 2x plus x squared e to the x. Okay, which one of these is it? I think it's C, right? This one has 3 terms. X squared e to the x, yep, I've got that. 2x e to the x, yep, yeah, so it's C. Number 7, a particle moves along the x-axis so that at any time t greater than or equal to 0, its acceleration is blah. If the velocity of the particle at t equals 0 is v of 0 equals 7, and its position at t equals 0 is blah, then its position is, okay. I think this problem showed up in one of the review problems. Anyway, since the acceleration is -4 sine 2t, what I can do is repeatedly anti-differentiate to get the position function. But each time I do that, I'm going to get an arbitrary constant, and I need to figure out what it is. The velocity will be the antiderivative of this, which I think is 2 cosine 2t. Let me just check that quickly by taking the derivative. If I take the derivative of this, I am going to get a negative sign because the derivative of cosine is negative sine. And this is going to become a 4 because of the chain rule, right? I'm going to get another copy of 2. So the antiderivative is 2 cosine 2t plus some unknown constant c. They tell me, though, that v of 0 is 7. I can use that to find c. By the way, that does not mean that c is 7. A lot of people seem to be thinking that. That's not true. It means that when you plug in 0, you get 7. So 7 equals 2 cosine of 2 times 0 plus c. So it's 7 equals cosine, this is cosine 0, which is 1, times 2, which is 2. So it's 2 plus c. That means that actually c is 5. So therefore, my velocity function is 2 cosine 2t plus 5. Now I do the same thing to find the position. X of t will be the antiderivative of this guy. I think that's just going to be sine 2t plus 5t plus c. Does that work? If I take the derivative of this, do I get 2 cosine 2t? Yeah, that's right. And then they tell you that x of 0 is 0. So that means replace t with 0 and set it equal to 0. So 0 equals sine of 0 plus 5 times 0 plus c. Oh, that whole thing is 0. So that's telling me that, in fact, 0 is equal to c, which means that my position function is sine 2t plus 5t. So therefore, what is, oh, that's the answer to the question, right? So it looks like it's A. Number 8. The graph of f double prime, the second derivative of f, is shown above. Which of the following could be the graph of f? Well, f double prime, one of the things it does is it gives you information about concavity. When f double prime is positive, the original graph will be concave up. When f double prime is negative, the original graph will be concave down. So right away, I know that the correct graph has to be concave up on the sides here, like on the left and on the right, because f double prime is positive there, and concave down in the middle. So which graph has that property? Not this one. Like, this looks like it's concave up at first, and then concave down here. That's not right. I mean, I think just thinking about concavity alone, I think it's got to be C, right? Because this graph is concave up in the middle. Or sorry, other way around, D, right? Because we want it to be concave down in the middle. Concave down in the middle, and then concave up on the sides. So my answer would be D. 1 second. Anyway, number 9. When x is equal to 2e, this also showed up in a review problem. This is giving you the derivative. This is the second limit definition of the derivative. So what this is telling us is really to just find the derivative of a certain function and evaluate it at 2e. What is the function? Well, it's natural log of x. So this is just telling you to find f prime of x, which is 1 over x, and evaluate that at 2e. So f prime of 2e, that would be 1 over 2e. So that's A. Number 10, if dy dx equals blah, then this guy here, that just means the third derivative, right? So they're saying, find the third derivative and plug in 2. So what is that? Well, the first derivative is this guy, so I just need to take the derivative twice. So y double prime would be 4x cubed minus 6x squared plus 3, and y triple prime would be 12x squared minus 12x. So evaluating this guy at 2, that would give me 12 times 2 squared minus 12 times 2. So therefore, y triple prime of 2 is 48 minus 24, which is 24, so I think it's b. Number 11. Let f be the function defined above. What is this integral? So this, of course, is the area under the curve. What does this function look like? If you think about it, for x less than 0, it looks like x squared. At x equals 0, it's just got some random whole, like the value is just -1. And then for x greater than 0, it's just x. All you need to do is compute the integral separately. So I would just first integrate from -1 to 0 f of x dx, and then integrate from 0 to 1 f of x dx. And if I split the integral that way, on this interval from, oops, that should be a minus sign. On this interval from -1 to 0, the function is governed by x squared. So this integral is integral from -1 to 0 x squared dx. On this interval from 0 to 1, the function is governed by just the function x. You might be wondering what's up with the -1. Doesn't make any difference. That's like a little dot in the middle of the graph. That's not going to change the area. So 1/3 x to the third evaluated from -1 to 0. I don't really have a good vertical bar in this equation program, so I just have to sort of type evaluate. Plus antiderivative of x is 1/2 x squared, and we're evaluating that from 1 to 0, 0 to 1 rather. So this first guy is 1/3 times 0 to the third minus 1/3 times -1 to the third, and then the second guy is going to become 1/2 times 1 squared minus 1/2 times 0 squared. So we just have positive 1/3 plus positive 1/2, which is 2/6 plus 3/6, which is 5/6. So I think it's A. 12. Given that blah, 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 what is dy dx? This is just implicit differentiation. So take the derivative of both sides, being careful to remember that y is a function of x. So derivative of the left-hand side is 3 minus secant squared y prime equals derivative of 4 is 0. Now I just need to solve for y prime. So subtract 3. You can forget about the minus signs. And then divide both sides by secant squared y. That's not one of the options, but that's just because 1 over secant squared is the same thing as cosine squared. So this is 3 cosine squared y. 13. For time t greater than 1, the position of a particle moving along the x-axis is given by blah. Okay, so that's a position. At what time t in the interval 1 to 16 is the instantaneous velocity of the particle equal to the average velocity of the particle over the interval blah, blah, blah. This is kind of like a mean value theorem problem. So what is the average velocity over the interval? That's just the average rate of change of the position function over this interval. So p of 16 minus p of 1 over 16 minus 1. What is p of 16? That would be root 16 minus 2. So 4 minus 2 is 2. What is p of 1? I think it's -1. So divided by 15. So that would be 3 over 15, which is 1 over 5. And the question is, when is the instantaneous velocity? In other words, the derivative of position. When is the instantaneous velocity equal to that number? So velocity is, of course, p prime of t, which is 1/2 t to the -1/2, which is 1 over 2 squared t. And I want to know, when is that guy equal to 1/5? So set it equal to 1/5 and solve. Maybe cross multiply. So 5 equals 2 root t. Divide by 2. square both sides. Looks like it's C. 14. If f is differentiable and y is blah, what is dy dx when x is equal to 3? I'm just going to take the derivative and use the chain rule. Careful though, because it's like multiple chain rules. Outside function sine, so I get cosine, leave the inside alone, times the derivative of the inside. Well, the inside is also a composition, so the derivative of the inside is f prime of leave x squared alone, and then times 2x. So that's the derivative in general. What's the derivative specifically at x equals 3? Well, that would be cosine of f of 3 squared is 9 times f prime of 9 times 2 times 3 is 6. Is it D? Does that match up? 6, cosine of f of 9, cosine of f of 9. Yeah, it looks like it's D. 15. The graph of g prime, the first derivative of the function g, consists of a blah, 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 blah. If g of 0 is 1, what is g of 3? Later value equals earlier value plus net change. So g of 3 equals g of 0 plus the integral from 0 to 3, g prime of x dx. G of 3 is what I want to know. I know what g of 0 is. It's 1. So the question is, what's this? Well, I have a graph of it. Integral from 0 to 3, that's just the area of the shaded region underneath the circle. And then this like smaller triangle. Notice that it's up to 3. It's like not the whole triangle. It's just this half of it. Okay, so what's the area of the quarter circle? Well, it's like pi r squared divided by 4. R is 2, so pi times 2 squared over 4. Plus, what's the area of just this little triangle here, like this guy here? Well, it's 1/2 the base. The base is only 1 times the height, which is 2. So this means g of 3 is 1 plus, that's just pi plus 1. So 2 plus pi plus 2, b. 16. Let f be the function, blah, blah, blah. What is the maximum value on the interval? Maximum value, you're talking about absolute max. So you're going to make a list of your critical points and your boundary points. So obviously the boundary points are 0 and 6. So the absolute max might happen at those points. We also should look at critical points. F prime of x is 3x squared minus 12x minus 15. Set this guy equal to 0. You can pull out a common factor of 3. And then I can factor x minus 5 times x plus 1 equals 0. So I get x equals 5, negative 1. But of course, negative 1 isn't in the interval, like it's not inside of 0, 6. So you should really just forget about the negative 1. So I have these 3 values to look at, 0, 6, and 5. So which one produces the biggest value? Well, you just got to plug them in to find out. Obviously, f of 0 is 0. Okay. What is f of 5? 5 cubed minus 6 times 5 squared minus 15 times 5. 5 cubed is 125 minus 6 times 25 is 150 minus 15 times 5 is 75. So that's negative 25. I think that's negative 100. And then f of 6, that's 6 cubed minus 6 times 6 squared minus 15 times 6. First it looks like it's going to be bad, but this term's actually 0, right? It's just 6 cubed minus 6 cubed. And then minus 15 times 6. Well, I don't know. I can just stop here. This is a negative number, okay? It's some negative number. So obviously 0 is the max value, right? 17. Oh, this is a problem you should skip. Yeah, this is a problem that you should skip. Basically, this involves antiderivatives involving inverse trig functions, which we don't cover, because very often, like, there won't even be a single question on those functions on the entire test. It's just not worth doing. So skip. Essentially, if you see something involving like inverse trig functions, like arctangent, arcsine, you should just skip them. Okay, you don't know how to do it. It's not worth learning either. It's really not worth it. 18. If you want to know how to do it, I think you have to complete the square, and then it's like an arctangent thing, but whatever. Anyway, 18. Let f be the function defined by blah. What is the approximation for f of 10 found by using a line tangent to the graph? So that means you want the equation of the tangent line at 8, 2. So start by writing down point slope form. The point in the line is, of course, 8, 2. The slope, that's going to be the derivative at x equals 8. Well, f prime is 1/3 x to the negative 2/3, which is 1 over 3x to the 2/3, which is like 1 over 3 times the cube, well, whatever. It means 1 over 3 times the cube root of x squared. So if I evaluate that at x equals 8, then I get 1 over 3 times 8 squared, well, 8 to the 2/3. So that's, you can either square 8 and get 64, then take the cube root, or you can take the cube root first, then square. It's actually easier that way. Cube root of 8 is 2. Square that, you get 4 times 3 is 12. So 112. So the equation of my tangent line is y minus 2 equals 112 times x minus 8. So therefore, I want to approximate the value of the function at x equals 10, so I plug in 10 for x. So this means y minus 2 is equal to 1 over 12. Oops. That should be an 8 times 2. So that's y minus 2 is equal to 2 over 12 is 1 over 6. So y is equal to 2 plus 1 over 6, which is 13 over 6. Looks like C. 19. Limit as x goes to 0. If you plug in 0, you get 0 over 0. No surprise there. So you can either try to simplify or use L'Hopital's rule. I don't see a way to simplify, so I'm going to do L'Hopital. Take the derivative of the top and the bottom. That's 8x over 4e to the 4x minus 4. If I plug in 0 here, I think I still get 0 over 0, which means I can use L'Hopital's rule again. I take the derivative of the top and the bottom again. I get 8 over 16 e to the 4x. Now if I plug in 0, I get 8 over 16, which is 1/2. Looks like it's B. 20. Let g be a twice differentiable increasing function of t. Which of the following must be true on the interval t is between 0 and 10? This feels like a mean value theorem question, which says that under suitable circumstances, the instantaneous rate of change will equal the average rate of change somewhere on the interval. The questions are asking about g prime and g double prime and stuff like that, though. So yeah, so what I know is that the average rate of change of g over the interval 0 to 10 is g of 10 minus g of 0 over 10 minus 0, which is 220 minus 20, so that's 200 over 10, so that's 20. So the average rate of change is 20. Okay, cool. Now, the mean value theorem says that if you have a function which is continuous on the entire closed interval, including the endpoints, and that function is differentiable on the open interval, in other words, 0 to 10, but doesn't need to include the endpoints, then the instantaneous rate of change, like the derivative, will equal the average rate of change. This function satisfies those conditions. It says it's twice differentiable, which means a second derivative exists. You don't even need that. you just, all you need to know is that it's the first derivative exists. So yeah, so I think it's B. G prime of t is equal to 20, because that's telling you that the derivative should equal to the average rate of change at some moment. I have a slight suspicion that that could be wrong, and like I want to think about it a little bit more, but I think that when you have a question like this, you know, it's not worth sitting down and thinking forever and ever and ever about like, oh, you know, is it really this? Is it really that? I think a lot of these theorem-based questions, like questions that pertain to the mean value theorem or intermediate value theorem or whatever, like you really just want to cook up an answer kind of quickly and move on. You shouldn't sit there and like scratch your chin. I kind of want to make sure that the hypotheses are guaranteed here, and because sometimes these can be rather tricky, but I think the answer is B. 21, d dx of blah, 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 this integral function. You know, basically, this is the second fundamental theorem of calculus. You're just going to plug x cubed into this function, so you get natural log of x cubed quantity squared plus 1. But because the upper limit of integration isn't just a plain old x, it's actually a function of x, like it's x cubed, it's kind of a chain rule problem. And so then you're expected to multiply by the derivative of the inside function, which is 3x squared. So this would simplify to 3x squared natural log of x to the 6th plus 1. So that looks like C. 22. Shown above is a slope field for which of the following differential equations? Well, right away I noticed that the slopes are all 0 on the x-axis, and they're all 0 on the y-axis. So the relevant equation should be equal to 0 anytime either x is 0, which would correspond to the y-axis, or anytime that y is 0, which would correspond to the x-axis. C and D both fit that requirement, so I think it's either C or D, whereas A and B would be undefined for values of y equal to 0. But the slope is clearly not undefined when y is equal to 0, right? Like, when y is equal to 0, the slopes are 0. That's not undefined. So I think it's either C or D. The difference, of course, is the sign. If I look in this quadrant, I can see the slopes are negative. X and y are both positive in this quadrant, though. So x and y are both positive, and yet the slopes are negative. That tells me it's got to be D. 23. Using the substitution x u equals x plus 1, this integral is equivalent to, so they're just forcing you to use u sub here. So let's do it. U is equal to x plus 1. That means that du dx is equal to 1, which means that du is actually equal to dx. So therefore, this integral becomes x over square root of u, and then dx is simply du. Now at first it looks like, oh boy, this isn't any of the options. Yeah, it's true, it's not. But there's kind of a trick to this one. Like, how do you get rid of the x? It might feel like you can't, but look at this equation. You can actually solve this equation for x. It tells you that x is equal to u minus 1. So you can actually replace the x with u minus 1. This is a very unusual u substitution problem. Like, this is not typical, right? Like, this is not how u sub usually works. So, like, I think few people are going to get this. Because, you know, this business of, like, solving for x here, that's almost never what you do. So, it's kind of a trick problem. I wouldn't call it a trick problem, but it's kind of a weird one. du, okay. Yeah, I just split the fraction there, and then that's, you know, that's like integral of, why do I keep typing y instead of u? I don't know, I'm just making typos. So u over root u, that's u to the 1/2, and then minus u to the negative 1/2. du, I think I saw that answer, yeah, it looks like C. Okay, so there we go. I mean, if you were going to guess on this one, you could definitely say it's not D. That doesn't make any sense. How are the u's going to be on the outside of the integral? You know what I mean? Well, anyway, 24. Let f of x be the function blah, blah, blah. For what values of x does f have a removable discontinuity? I think you just got to factor this thing, right? So common factor of 2 in the numerator, 2 quantity x squared plus 7x minus 8 over denominator the minus 8 and minus 1, right? Yeah. So numerator factors as x plus 8 times x minus 1. Did I do that right? Yeah, I think so. So basically, this function is discontinuous at both 1 and 8. But after simplification, like after cancellation, this factor disappears, like the x minus 1 disappears. And that is telling you that x equals 1 is a removable discontinuity. However, the discontinuity at 8 doesn't go away even after cancellation. You have a vertical asymptote there. So, yeah, you have a removable discontinuity just at 1. 25, which of the following is a solution to the differential equation, blah, blah, blah. You're not supposed to solve the differential equation. Like, this is just saying, you know, like, I mean, it's a second order differential equation. Like, there's a y double prime here. So you're not expected to solve that. You're just expected to say, like, which of these 4 functions has the property that if you take the derivative twice and then subtract 4 times the original function, you get 0. That's just like saying y double prime is equal to 4y. So, like, taking the derivative twice is the same thing as multiplying the original function by 4. So, which function has that property? A definitely does, right? If you take the derivative of a twice, you're just going to wind up multiplying by 4. So that's it. I don't really even have to look at the other ones. C and D are close. You take the derivative twice on these guys, though, you're going to wind up multiplying by -4. So it's A. 26, the table above gives values of the continuous function f. Its selected values of x. If f has exactly 2 critical points on the open interval 10 to 14, which of the following must be true? So I know that f is continuous. I know that f has exactly 2 critical points on this interval. Which of the following must be true? This is a super annoying problem. Like, you see a problem like this, like, you should probably just skip it and come back, honestly. Like, they're quite tricky. They take a lot of thinking. I mean, I'll talk about it, but, you know, this is a problem that I would skip and just come back to. Okay, so how does it work? Which of the following must be true? A. F is positive for all x in the open interval 10 to 14. I don't see why that would be true. I don't see, I mean, it could be true, but I see no reason why, like, in between the given values of f, I don't see why the function couldn't, like, dip down to negative values in between. You know what I mean? Like, you don't know what's going on between 10 and 11. The function might dip down to be negative. So I don't think it's A. F prime exists for all x in the open interval. Why would that be true? Like, all you know is the function's continuous. Like, continuity does not imply differentiability. The converse is true. Differentiability implies continuity, but no, you can have continuous without differentiable. There's no reason to assume that the function's differentiable throughout this whole thing. There might be corners and stuff. So it's not A or B. C, f prime is negative for all x in the open interval. Again, I don't see why that would be. Oh, for all x in the open interval 10 to 11, huh? 10 to 11. And we're saying, maybe. Let me think. Because, I mean, what I noticed with these values is it goes down, so it's like overall decreasing on this interval. It might be doing like up and down, but overall it's down. And then on this next interval, it's up, and then still up, and then down. And so, like, you know, if there are exactly two critical points, then like one of them's going to be, one of those critical points, I think, is going to be like in here, probably. Or rather somewhere, somewhere on this interval, because it switches from 10 to 12, it switches because it switches from decreasing to increasing like at some moment on 10 to 12. Like it might start at 5 and then dip down to 0 and then start increasing again. So there's at least one critical point on 10 to 12. And then likewise, for the same reason, I think there's at least one critical point from 12 to 14. And we know that there are exactly two critical points. So, yeah, I don't think C is true. I don't know why that would necessarily be true. Like, the value of the function could dip down from 5 to like 1 or something really quickly, and then start increasing again. So by the time that it reaches 11, it's equal to 2. So like, the derivative would then be positive. So I think C is not true. So it's got to be D, just by process of elimination. As far as why is it D, I think that the argument here is that there's at least one critical point, like somewhere here and at least somewhere here, and maybe the critical point has to be on the interior of the interval, which means that it can't be at 12. But yeah, like I said, these problems, like, they're just so tricky and like, take so long, and very often like you sit down and you think through them and then you're just like, yeah, I still don't really know for sure if that's right or not. So I think my answer is D, but like, you should skip these stupid problems. 27, the positive variables P and C change with respect to time t. The relationship between P and C is given by blah, blah, blah. This is just a related rates problem. That's all it is. Except they give you the equation directly. You don't have to like do any geometry. So yeah, it's related rates problem. So just take the derivative of both sides. You get 2p p prime equals 3 quantity 20 minus c squared times the derivative of the inside function, which is negative c prime. So if I plug in everything that I know that p prime is 41, I know that c is 15, so I get 2p times 41 equals 3 times 20 minus 15 squared times negative c prime. C prime is what I want to know, and there it is, but I don't know what p is, so I have to go back and find it in the original equation. The original equation tells me p squared is equal to 20 minus c, which is 15, to the third. Well, that means p squared is equal to 5 cubed, so 125. So therefore, p is equal to either plus or minus square root of 125, which feels kind of weird that there would be two. Oh, they tell you the variables are positive. Yeah, so in fact it is the positive root. Which that simplifies as, that's like 25 times 5. So 5 root 5. So p is 5 root 5. So going back to this guy, I can replace the p. 2 times 5 root 5 times 41 equals 3 times 20 minus 15 is 5 squared times negative c prime. So what is this? This is 10 times 41, so 410 square root of 5 equals, what is this? This is 75. And then I'll put the minus sign there, c prime. So therefore, c prime is equal to 410 root 5 over 75. And that's got to be reducible, right? I mean, the top and bottom are definitely divisible by 5. I think that's 82 over 15 root 5. Oh, I lost a minus sign somewhere, didn't I? Yeah, there should be a minus sign here. There we go. So I think it's D. 28. Limit as x goes to infinity, or negative infinity of this guy. Well, as x goes to negative infinity, those exponential terms actually go to 0. Because like 2 to a large negative power is a very small number. So surprisingly, it's actually the 3 and the 4 that are the larger terms in the numerator and denominator. So the answer is 3/4. C. 29. The graphs of the function g and the line y equals x are shown in the figure above. The graphs intersect at blah, blah, blah. Which of the following expressions gives the area of the area enclosed by the graphs? I think 3 is sort of the traditional way that you would compute this, right? Because it's like the area between two curves is the integral of the top function minus the bottom function. But they change roles halfway through, right? Like from 0 to 1, g of x is on top and x is on bottom. So it's integral from 0 to 1, g of x minus x. Plus, and then on this interval, it's the reverse, right? X is on top, so it's x minus g of x. So the correct answer has to include 3. So it's either B or D. So that just boils down to, is 2 correct or not? Yeah, I think it is. I think it is. Because basically, the only difference between x minus g of x and g of x minus x is like the sign, like whether it's positive or negative. You know what I mean? Like on this first interval, x minus g of x would be negative because x is on the bottom. But then the absolute value function would make it positive. So I think 2 is correct as well. So my answer is D. 30. A student attempts to solve the differential equation, blah, 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 with initial condition, Steps of the student's solution are shown below. In which of the following steps does an error first appear? You got to be careful because there are probably multiple errors. You need to find the first error. So first one, step 1, it looks like they separated the variables. And that looks correct. Then they take the oh, that looks wrong. No, the antiderivative of 1 over y cubed is not natural log of y cubed. So my answer is step 2. Let me just double check that there's no mistake in step 1. Yeah, that looks fine. Yeah, so my answer is step 2. Okay, and that's the end of it. Cool. So now I think I'll pause here.